Please welcome Mr. Don Lambert of Miratech.
Thank you for the opportunity to tell you a little bit about some of the work we're doing at Miratech. In broad strokes, very broad strokes, our business is designing, building, and selling catalytic converters, mufflers, and related controls. Our focus is on stationary industrial engines, so we're not dealing with cars because they're not stationary, and they're really not of the size that really interests us and fits our business. And our focus is on emission and acoustic solutions. So we're looking at the engine exhaust and the engine noise coming out of the engine and finding ways to control those. One of the staff writers at NPR earlier this year was looking at some NASA satellite imagery of the US sky viewed from outer space. And one of the things they noticed is this big glowing cluster of light in the northern central plains of the United States. It's very big. It's as big as Dallas, Chicago, and a lot of major metropolitan cities, but it's seemingly out in the middle of nowhere. Well, it turns out what that is the Bakken shale play. It's flared natural gas from shale drilling plays in the U.S. And if you look down south around San Antonio, you can also see the similar flared natural gas from the Eagle Ford shale play. Now, these are primarily oil plays, so they're drilling for oil in these shale formations, but there is absent or insufficient pipeline infrastructure to carry away the produced natural gas that is also found with that oil. So flaring is what's done with this natural gas. Now, nationwide, about 1% of our produced natural gas is flared, but in the state of North Dakota, 29% of gas production is being flared right now, and that's tied to the Bakken shale play. So one would have to say there has to be a better use or a solution for this abundance of flared natural gas. Well, we think that one of the solutions is biofuel retrofits of the diesel engines that are used in the oil and gas industry. Now, these diesel engines in oil and gas are used extensively in drilling operations to power the generators and the mud pumps used on the drilling rigs, but they're also used for on-site power generation and liquids pumping in oil and gas. They're a great candidate because of their extreme duty cycle. They spend a lot of time under heavy load, they work 24/7, and they burn a lot of diesel fuel. And that's what makes them ideal. And the biofuel retrofit will substitute natural gas for a portion of that diesel fuel consumed by the engine. And because it's on engines used in oil and gas, this fuel source is readily available at the well site, and it would otherwise be flared. So the biofuel retrofit is really pretty simple in terms of number of components. What you're seeing here is the fuel gas train. This is regulating and metering the natural gas that is being fed to the diesel engine as a fuel source. And these items right here are where the gas is going into the engine to serve as its alternate fuel source in addition to the diesel fuel. And this is the human-machine interface. This is the control panel. So don't be fooled by the small number of parts and the apparent simplicity of the parts that go into this retrofit. There is a lot of knowledge intensity involved in the control system that makes these parts work and controls them to operate effectively. So why is biofuel a big opportunity? Well, it's all about the money, and the fuel cost savings are significant, especially when you're displacing up to 70% of the diesel fuel consumed by the engine with natural gas. This allows you to extend the run times of the diesel fuel engine on its existing fuel tank because that fuel tank was designed assuming 100% fuel consumption of the engine. This means less frequent fuel deliveries to the well sites, which puts a lot less wear and tear on our infrastructure to get the trucks there. We're using an available source that's right there, and it's a less carbon-intensive fuel source, so it should be lower exhaust gas emissions. Now, all of these benefits do not just apply to oil and gas engines. They also could apply to these engines used at data centers, backup generators, refrigeration containers, and more. This slide here details the fuel savings with a biofuel retrofitted engine. This data reflects the savings generated on a 1.3 megawatt diesel engine used in the Barnett Shale in an actual drilling program over a 20-day drilling cycle. The column on the left represents the current practice, with red representing the diesel fuel costs alone. $69,000 in diesel fuel costs on one engine over a 20-day drilling cycle. In the middle column represents the same engine operating in biofuel mode, supplemented with natural gas. $39,000 in cumulative fuel costs. A $30,000 savings in fuel cost over 20 days of drilling with one engine, and there are typically 3 of these on one drilling rig. So you would think, with project economics like that, so compelling, that everybody would be doing this. Unfortunately, there are obstacles in the path, and the big one is the Federal Clean Air Act. There is an anti-tampering provision of the Clean Air Act that is mentioned on this label that you'll find on engines that are manufactured. This provision had good intentions. It was rooted at times when there was the option of putting leaded gasoline in a car that was meant for unleaded fuel. But it did not take into account the onset and the discovery of cleaner burning fuels and the ability to take engines with long useful lives and make them run on newer, cleaner fuels as they become available. There's also a backlog of rulemaking at the EPA that makes it very lengthy and very difficult to get an affirmation from them that this would be an acceptable technology. And because so much of this is tied to oil and gas and fracking, which is a very polarizing subject, there are a lot of strong, loud, what I call know-it-all personalities that have hidden agendas because they don't like fracking, they don't like oil and gas, or they just don't like engines in general. So what is the path to expanded biofuel retrofits? Well, there are the obvious things of advocacy, demonstration projects, but our role at Miratech is really what you see in red here. We want to test the emissions on these engines, develop a product that could remedy any deficiencies identified in the emissions that were tested, and then promote to the EPA and get their affirmation that this is a viable technology and it does no harm. In other words, we want to change the rules of the game. We want to produce credible research, compelling results, and work with the EPA and not wait for them to contract someone else to do the research. So here's a summary of what we studied. We looked at 4 engine operating modes of the diesel engine. We looked at the stock diesel engine running on straight diesel fuel, and then we looked at the emissions from that engine operating in the biofuel mode with natural gas substituted as part of the diesel fuel consumed. We looked at the emissions then with the Miratech catalyst applied in both modes of operation. We operated the engine over a variety of load points, and we tested multiple pollutant species that are regulated. And the ultimate goal of our research was to control the biofuel engine emissions with the Miratech catalyst to equal or lower emission levels than the stock diesel engine's certified emissions at the factory. That was the goal. And the next couple of slides summarize the emissions that we found. This shows you the carbon monoxide emissions in each of those 4 modes of operation. The main things that I want you to pay attention to are the red bar and the green bar. The red bar represents the diesel emissions, the stock diesel emissions, as it would have been certified from the factory. The green bar represents the biofuel emissions when the engine is operating on biofuel controlled with a Miratech catalyst. So the goal is achieved when the green bar is less than the red bar. And you can see that at each of these load points, we have achieved the goal. We have a successful product. We also tested the NOx emissions over the same set of scenarios. And again, the red bar represents the stock diesel engine emissions. The green bar is the biofuel-operated engine with Miratech catalyst. And when those emissions are lower than the red bar, the green is lower than the red, we have succeeded. And in all but one load point, this middle load point, we have lower NOx emissions than we do from the stock diesel engine. And we think that we can remedy this one point with some simple tuning of the system. So in summary, with the biofuel retrofit, using the Miratech oxidation catalyst, we can control the NOx and the CO emissions to levels that are at or below the factory-certified emissions for the stock diesel engine. We also tested the formaldehyde emissions from this engine in these operations, and the Miratech catalyst achieves a formaldehyde emission reduction that is compliant with EPA's RICE-NESHAP regulation, which affects stationary engines in the U.S. And as expected, because we're using a less carbon-intensive fuel blend in the engine, our CO2 emissions are lower as well. So what are the outcomes? Well, there have been a lot of hesitant biofuel prospects out there that have not wanted to adopt the technology out of fear of the consequences of this anti-tampering provision of the Clean Air Act. But now, having seen the research and the results that we've demonstrated, they have the comfort and the confidence that we have a solution that will remedy any of those emissions problems by keeping the emissions levels below their certified stock emissions. It also presents opportunities for emergency genset operators to expand the use of their engines and remain in compliance, and we've commercialized a formulation that does it. Drilling companies are recognizing significant fuel savings, and this puts a stranded natural resource to good use. And EPA has invited both of us, GFS Corp and Miratech, to present these findings this fall so they can see the results of our work. Thank you.